Hello, and welcome back to the Rockcode Academy. I'm your host, David Flanagan, although you can find me across the internet as Rockcode. Today, we're back for a new episode of Rockcode Live, where we take a look at the local development environment experience, or at least developing locally against a Kubernetes cluster for all of your Kubernetes cloud-native software development needs. This is a perpetually difficult problem to solve, and today we're taking a look at a new-ish solution called MetterD. To guide us on our journey to explore this technology, we have Aviram and Isle from the Metal Berko team. Hi there. How you doing?
Great.
Is it Metal Bear Co or just Metal Bear? I never know whether to call you by like the Twitter handle or like by your company name. But
Yeah, Melba was taken, so we added a
By
code.
a lot of people, a lot of different people took it. So.
Yeah.
nice. Well, before we dive into kind of what MetterD is, can you both just take a moment to introduce yourself, share a little bit more about you, and then we'll kick things off. Let's start with you in the middle, Aviram.
Hi everyone, I'm Aviram. I'm Melba CEO and maintainer. My experience is mostly security low level, but less experience was backend engineer. I met Eyal in less company, and where we faced a lot of issues together in the backend side, and that's what led us to build MirD and start Metalbear.
Yeah, and I'm Eyal. I'm Viram's partner and CTO. I live in Tel Aviv. I have a technical background that I won't bore you with. My dog here is at my feet. He's very uneducated, so please excuse any sharp yips. And happy to be here.
All right. Thank you both for joining us. All right. So we're getting a few hellos in the chat and a comment about the audio. I'll look into that in a second. Don't worry. And we'll get it fixed in a moment. Maybe we can start off then by understanding what MetterD is and the problem that it's trying to solve. Now, I said this at the start, right? I feel that this is just something that's always been difficult in Kubernetes. And I'm hoping what we're going to look at today, you're just going to give me like the golden path, the shining light that just makes all of this easier. So let's cover what is MetterD and the problem that it addresses.
Yeah. So in the easiest way to describe MirD is the way to execute your local process service in the context of the cloud environment. And what it means is that MirD plugs into your IDE as a plugin that you can just enable, disable, or comes as CLI, which you can use to execute your services. And once you enable MirD or execute the process with MirD, what it does, it brings you the environment variable of your remote service. It lets you access the remote files without doing any mounts, without copying, doing any changes of your local machine. Everything is done in the process level. It lets you access the remote services. So anything you have on the remote cluster that is accessible to it, Kafka, Redis, any network resource is available also to you, including DNS. And the fourth thing that it does, it lets you get incoming traffic of the service. So that comes in three modes. The first one is enabling. So yeah, you have something to say. Okay. And three modes of the incoming traffic is you can either mirror the incoming stream, so any stream incoming to your remote service is also duplicated to your local service, hence MirrorD. Secondly, you can steal traffic of a specific port to your local service, or the third option is that you can steal HTTP traffic based on headers or API paths and HTTP filters in general. And that's like the gist in a few words.
Awesome. All right, I'm just going to mute you for a second to see if a bit of noise goes away. It did.
So the noise is coming from me?
Yeah, I think it's like, I don't know. It's like wind? I don't know. It's like a weird background.
Is it windy where you are?
I have air conditioner on. Maybe it's better now. I'm using the camera
yeah.
microphone now.
Yes,
better?
the AC noise has now disappeared. That is amazing. Well done.
Well, so I was understood. Like I can repeat myself. I jumped into directly what it does instead of talking about a problem, which is what I usually do because
Well,
I
I
like to
think
jump
I
into
could
stuff.
cover the problem. Like, I have explored a lot of tools. I've explored a lot of tools in the Kubernetes space, especially in the development space. And a lot of them all take the same approach to this developer experience thing, right? Which is to, it's funny that the person that reported this audio thing and has now just given us a thumbs up saying it's fixed, his name is Wind. So, yeah, I don't know why I found that funny. But they all take the same approach to this problem of providing the developer experience, right? And that seems to be, we're either going to do some weird file system mount into a remote container, which we all know is slow, right? This is even slow in Docker Desktop for local development, right? We can't even build a PHP app in an interpreted language and sync the files. That doesn't mean we have to wait 5 seconds on a refresh of a web page, right? And if we can't do that, we can't do it over our network. And the other approach, which we've seen through tools like Scaffold, is, well, actually, let's just build a container image locally because that should be faster. But then we have to sync the missing layers for that container image to the remote cluster and get it in some way. And they all make this a very file system centric problem. And what I like about MitterD is that there is no file system problem. You've made a networking problem, and you tackle this by doing magic, as far as I'm concerned, with the way that the packets are sent between the cluster back to the user thing in a way that gives them not just a remote developer experience, but an integrated developer experience where it allows them to communicate and consume, work with cluster services and all of that. Now, I know my knowledge here is very fuzzy, so I'm going to need you two to jump in and talk a bit more about why you've went down this approach and how this actually works from the magic networking side of things.
Yeah. So I think it starts from the experience that me and Eyal had in the last company, and that's where the most valuable process step in the process we had is deploying to staging. So we had like a vast data for each customer, everything very complex, and each customer, it was big enterprises, and each customer their own features and data, and it involved AI and ML. So a lot of stuff needed to be set up just to test the most basic things. So when you write unit tests, integration tests, it never really covers what you would see in production, what you'd see in real life. And that's why staging was the most valuable environment, because we had some of the traffic duplicated into it, so we could have real data to interact with. And what happened is that we set up the very, very cool stage environment where we can throw our versions at, but then we had a queue where each engineer needed to see that there's no other engineers deploying the service, and each time the service vendor, you didn't want them to cross contaminate each other. And then you had the issue of that, okay, you had an issue, you need to roll forward or roll back. So what usually happens in companies is that they just say, okay, so staging needs to be stable. So we need to do as many tests as possible. So they do TDD, there are tons of tests, and then they hit production and still it doesn't work. Why? Because Azure doesn't deploy the API version you expected. And that's really sorry. Like I had a bug with Azure, Azure Blob Storage. It was a specific version in our region wasn't deployed yet, but the SDK had it. And so it worked locally because I used region, but then when I deployed it to a real environment, it didn't work and it broke. Of course, that's an issue also from the vendor side. But I mean, those kind of mistakes happen. And and that led us to realize that we want to enable developers and engineers use staging as their development environment. And we started by just letting them get plugged into staging so they can work continuously against it. And as we develop more features, we enable better concurrency work in the staging without breaking each other. So that's like the general flow of mind we had.
Okay. Like, this is one of these weird subjects, right? Like, would you just it feels to me I could let people test and prod with this tool, right? And at what point, like, is that a sign of maturity of your infrastructure if you could do this in prod, or would you just always do the staging? I don't know. Like, staging to me always just feels like Yeah,
a really
go for
good question, because that's sort of where we started. I think like, why not do it in prod?
it.
Which it became very clear very early that no one's going to run it in prod anytime soon. Like, you need an established product, and it's sort of a spectrum. You got prod, which is of course the best replication of production, but then you've got staging, which is on one hand a good replication, but you're not as scared of trying tools on it, breaking it, etc. And so, that's where we landed for the initial stage. We are seeing some organizations that are less afraid of deploying things on production, and so are trying to do it without our encouragement. And we are thinking of it as a possible future for Merdy, but we think that there's enough, meat in staging for the time being.
Yeah, I mean, I don't want to turn this into a political discussion about testing and prod or whatnot, but I've yet to see a good staging environment that actually has, they're always very good from an automation point of view, and your production environment really does look like a staging environment. And this is just the people that I've seen. I'm not saying this is all Kubernetes clusters in the world, but the pit that it always falls down is when it comes to data, the actual usage patterns within that cluster. Now, I have seen people that just take a 7-day-old snapshot of production and put it in staging, and I think that's a terrible idea as well. But again, not the topic of today's discussion. But I do love that we could use the traffic, cloning stuff within MillerD to inject something into production, get real data without the blast radius of that interception being real data. We can get into that as we cover the usage and take a look at it in more detail.
I wanted to add that in the first version of MirrorD we released, it was just a VS Code extension, very barely. It was a barely working MVP that we just wanted to see how people reacted. And when we posted it to Hacker News, we did a show HN. We also put it in the marketing and all the content. We said mirror production data traffic into your local machine, and all the people in Hacker News were like, "No, don't do that." So so it was the immediate typical Hacker News response that, "Oh no, you're insane! Don't do that." So yeah.
Well, of course, the risk appetite from organization to organization is always very different, and Hacker News, I don't think they're my people there, so I am less risk averse. So we have a couple of notes and a question, I think, in the comments just now from Wind. So let's see. Wind is saying that they have an environment for end-to-end testing. Would this tool help developers to work when they run their tests? They're looking at this from the SRE perspective, where they don't have much dev insights.
I just jumped into answer, and so the answer is yes. We see people running. You can run tests. You can run anything that you can run, and we also see companies integrating MirrorD into their CI. So now you have imagine you have your stable cluster, and let's say you have all the stable version of everything. So instead of doing blue-green canary deployment into the real environment, you just run the CI using MirrorD inside the staging cluster, and then you get partial traffic just for your test to test it. And once it's done, you can deploy to the real environment. So that's another use case we see. That's less on our focus right now, but MirrorD is a tool, so you can do whatever you want with it. So and we see that happening.
Cool. All right. So there was a diagram that we said we were going to talk about how MirrorD. In fact, before we even get to that, am I pronouncing it right? I know that's the tech question that everybody always asks, but is it MirrorD? Is it mirrored? Is it something peculiar? How do you see it?
It is MirrorD. Tragically, a lot of people do think it's mirrored, but it's the tech pronunciation, the Linux pronunciation.
All right. And how do you spell that kube command? How do you pronounce that? The tool that
you mirrored.
Oh no! Sorry, I'm now just asking how you pronounce kubectl. Is it kube control, kube huddle?
Kubectl.
Yeah, kubectl.
All right, cool. I'll put you in that
SQL or
bracket.
SQL, that's that's the real heat discussion.
Oh, I don't know if I'm on board with SQL, but again, I don't want to turn this into any sort of pronunciation war. Okay, so I'm going to pull up the website and let's dive into a little bit more about the technical understanding of how this all works. So here we have the MetterD website. If people want to check this out, it's available at metterd.dev. And if we go back to the home page, there's a diagram at the bottom that tries to talk about how this works. Do you want to go over this, either of you, and talk about the networking stuff that's going on within the cluster?
Yeah, let's really quickly go over what MirrorD does, right? So MirrorD has two components, the layer or the client and the agent. And what happens when you run MirrorD is that the layer is injected into a process and it overrides low-level function calls. So, file reads, traffic, outgoing traffic, etc. And then it proxies them essentially to the cloud through the agent. Right, so the agent, when you run MirrorD, it's set up. Then it's a temporary agent. It cleans itself up when you finish execution, and it runs adjacent to the pod that you want to impersonate. And so the most basic flow to illustrate this is a file read, right? So if your process is trying to read a file locally, MirrorD would intercept that call and then pass that to the agent, and the agent would read the file from the pod instead, right? We do the same thing for traffic and for environment variables, and that's how we achieve sort of a hermetic wrapping of your local process to make it think that it's running remotely, even though the code is actually running on your local machine.
Okay, so is this like an LD preload syscall hijacking within the pods? Okay. So, I mean,
Not within the pods. The injection happens locally. On the remote side, we don't touch the real process. We just enter the Linux namespaces of it, so we can access the same resources. But we don't touch the remote process unless you do a pause, and then we pause the process. But it's a more advanced feature.
okay. And I guess you are kind of doing file syncing, but it's very selective based on the read syscall, right? I mean,
yeah. So
if you actually read a file, it's still, I mean, it's not syncing a whole file system, but you are literally transporting the bytes of that file, right?
Yeah, but usually what happens is that the file reads are usually for secrets, mounts. Like usually you don't really read the data unless there's like maybe some static database. But I don't think we have seen that use case very often. And then another thing that's very cool is that everything is configurable. So you can say this regex access it locally, this regex access it remotely, and then you can mix and match. So if there's a big file, you can just make it read locally, so you wouldn't have any latency there.
Cool. I think it's time to jump into our live section and actually just show this working so that the audience can get a feel for what the process looks like to actually build and develop using MetterD as their tool. So to do that, I believe Avram is going to guide us through a demo.
Yes, absolutely.
You happy to do that now?
Yeah, happy to do it always. That's like Eyal is always joking that I'm like, oh, you want? I'm always offering people to see a demo, and he's like, stop offering people demo.
All right. Well, if you get that ready, we've got one more.
Now it's appropriate, right, Eyal? Yeah. So just to put it in context, so in our demo we set up a very. By the way, you can see my screen, right?
Yeah, but do you mind if I throw a couple of the questions from the chat at you first before we dive into that?
Sorry. Yeah,
sure. All right, so we've got Wind back, and Wind was asking, is the partial traffic just splitting on entry to the pod or container?
Yeah, so there's that's configurable. So the default configuration would be mirroring. So it's not splitting, it's just you got the same stream as the remote pod. But if you hijack in the traffic, we call it stealing, that would, we split it. And then based on the filters or based on just the port being stolen as well, and we plan to have more capabilities on top of it based on the requirements from the users.
Okay. And in true Russell fashion, who's a regular on this channel, there's always a funny comment followed by a real question. So apparently SQL is pronounced squirrel. I haven't heard that before, but feel free. Now the question is, does MitterD work with multiple users at the same time? Does it separate the hijacking? If two devs A and B use MitterD, would dev A hit dev A hit dev B's service?
Yeah. So it depends on the exact configuration. Like if you do mirroring, then you both will get a mirror probably, and that would probably work. But that's what we call mirror default. That's why we build what we call mirror default teams, which is a control plane from mirror D. And what it enables you to do is really work concurrently multiple users on the same service exactly. So if you and I work on the same cluster, but each one of us works on a different service, then we wouldn't have conflicts. But if we want to work on the same service, then the mirror default teams enables you to have multiple sessions on the same target at the same time by giving you synchronization primitives and also making sure that you don't override each other.
All right, awesome. Wind also says thank you for that answer. So I won't interrupt you anymore. Please feel free to carry on with your demo.
Yeah, feel free to disrupt me. I like disruptions. And by the way, feel free to help me clear this up. But this is our setup. It's supposed to be quite cover very common use cases, but be very small. So bear with me. The cloud in our case is me, the client. I can access IP visit counter, which implements one API called count. And what count does, it takes my IP and then calls another service called IP info that provides information about that IP. It saves the IP to Redis in order to store the amount of the count of how many times I've seen this IP. And it also sends the IP to a Kafka topic, which another service consumes and just prints the messages it gets from them. So that's the setup. Many questions about it? Does it make sense?
No, makes sense.
Awesome. David, what do you prefer, IntelliJ or VS Code?
I have a very strict rule, and I have no GVM installed on any of my machines. So, yeah, I guess VS Code wins.
I thought you weren't doing politics.
I mean, it's tech. Everything's politics, right? But I mean, no, I can't do it. I can't run the GVM. Sorry.
Yeah, I can blame you. So we'll use VS Code for our example. Let me find my window.
We also accept NeoVim, Vim, or Helix. All acceptable answers.
Yeah.
What IDE do you use, EL?
I'm VS Code. I was just trying to rile up a conflict in VS Code.
I mean, I've got to say, like VS Code or other language server supports. I mean, it's just it's still quite fast, even though it's an Electron-based application. I've got to say, they got a lot of things right. It's a pleasant experience.
Okay,
yeah,
so
and
you
I
can
was
see me
sold on IntelliJ. So sorry, go ahead, Aviram.
So you can see my screen now, right?
We can see your VS Code. Yep, you've got a terminal at the bottom. You've got some code above it. Yes.
Yeah. I zoomed in. I did. I like it. The zoom is okay. You see it good enough.
One more wouldn't hurt. Yeah, I think that's good. There.
Awesome. So this is our cluster. It has nothing that is not the service that we talked about. So we have the IP info service, IP info consumer, and an IP visit counter. I need to restart the consumer because it dies. I didn't do any health check there. That's like I'm not a very proficient Go, and I just build it very fast.
Wow, a rollout restart instead of just deleting all the pods. That's classy.
Yeah. Oops. So this is our cluster. So we have all the services here, And we'll start by just showing like this. The API, what it does. So this is on the remote. You can also, like other people on the stream watching us, you can also access it and see it for yourself. This is all real. And you can see the count increasing each time I hit the request. Now, I want to start working on it. So this is the service, this is the actual code, like a very complex code that does this magic. And we'll start by putting a breakpoint on the main just to show how it starts working. And when we install MirrorD, that's what we get. We get a little, I'm not sure how you call it, like label, button, I don't know, menu, which you can click. And once I click it, it enables MirrorD. So this haven't done anything. This just like toggle the usage of MirrorD. And the next time I run my service, it would use MirrorD. And this one would use a configuration that I will show in one sec. So I can use it without any configuration, but just for the sake of this demonstration, I would use this configuration. It's not supposed to be here. So what I put in the configuration is the target. Maybe I'll remove that to show you how it works for like the more common scenario. And yeah, so this is configuration. We'll steal traffic only that has this header, and we'll read remote files. We'll have outgoing traffic, and this is pretty much default. This is the only custom thing that I've done in this configuration. Yeah, so now I can just go into my code, click debug. Oh, don't update now. Sorry. We had a new version and I haven't run it yet, so hopefully it won't break anything.
We're back to testing in prod again. That's okay.
Yeah.
So can I just clarify a few things? This is a MetterD VS Code extension, and just by being in this main.go for the IP visit counter, the MetterD extension has this JSON file loaded and knows how to replace that service or how to intercept the traffic for that service within the cluster.
Yeah, so the configuration file isn't required. Like what we do is pretty much everything is very self-configured and very opinionated. So you don't need to configure like what I show right now. So I remove the target, so now it will let me choose. So now I run it, and now I can choose which target I want to mirror. So I'm running the IP counter service, so I will mirror that. And then it does, this is when we spawn the agent, and now it's ready. And now we see the service running, and the breakpoint is hit. And you can notice that the process, everything is running locally, the service itself. So now we've hit the load config breakpoint. We'll step into that. And what we do is pretty much very common thing. We load settings from the environment variable. So I can just go over that. And then let's inspect the config. We can see that we got some information from it. That's not from my environment. That was obtained from the remote service. And now, what's a very common thing we do is we read files for secrets and stuff. So in this case, we have this path we want to read. This path doesn't exist on my machine. Either it's mounted, there's no any mount. Though it's running locally, that's what part of the magic of MirrorD. So we'll get here. And now we can see that it was loaded. And the loading happened from the remote pod. So we actually got the remote file. So if you have any secret, anything that comes from the remote pod, you immediately have it because you have the environment variables and you have the file access. So now it goes through connecting to all sorts of stuff, and we'll just skip that. And we have the service running now. And you can see it's running on port 80, which is the same port the real service is running on. Now I can do curl, and you see that nothing happened. Why nothing happened is because I've put in my configuration file, not this configuration file, that I want to steal traffic only with this header. So now I will place this header, and the breakpoint is hit, and you can see also the request is being stalled. Why is it stalled? Because it's me holding the request, and I didn't need to respond. So I just let it go. And you can see the response coming in.
Nice.
Yeah. Any questions so far?
No, it makes a lot more sense just in that one little demo. I was thinking about it completely the wrong way when I was talking about, the reads, doing the interception in the pod. But of course, this is all running locally, and it's to make sure that when I want to consume Kubernetes secrets or even environment variables for service discovery, any of this stuff, that it works even though we're running everything locally. Well, yeah, just like a light bulb moment. It's like, oh, of course, of course, it makes total sense. I was just being a bit daft, but I've only had 2 coffees today, so that's okay. So that really helped. Good.
Yeah, I think one of the things we see common with people is that when we explain about MirrorD, like verbally, and also from documentation, they don't really get or grasp. Like they imagine a lot of like people promise 30 seconds and very quick and magic, and like they don't expect that. and when they actually see a demo of MirrorD, they say, "Oh, this is actually different than what we've seen in other things." So. Yeah, I think a demo also really helps. So this is the more simple example. And now we can go into a bit more deeper example. So what we do in the request, so I said it sends a request to the upstream service, and the upstream service, we propagate headers. Which is very common. You can also use observability headers that usually propagate to have like a trace ID. And you can use that also to steal traffic based on that. And then when we do that, we go to the other service, which is the upstream service. And I will also steal based on the same header filter. So now let's go to the code of the IP info. And wait, because it contains something I didn't want to show. 1 second. I don't see that. So this is my code, and now I will run it. And if you notice, the info it returned was loves coffee. And now this version that I have locally is loves AAA, which is AAA is an acronym for, I don't know, something.
So DNS records for IPv6, right?
Yeah. So now I can, you can see that the real service is answering, and when I do the header, it propagates and then gets to me. So now I can steal a service inside the cluster that isn't even being ingressed and exposed externally. And now you can see the response is also for my local service. And that's like the very basic demo. I think we can stop it here for now. Like we can go like more interactive, but
So this calls that this is working with. Right? If I try to read from the environment, it's intercepted. If I want to read from a file, it's intercepted. If I make a DNS resolution or network request, I'm assuming that gets intercepted and handled appropriately too. I mean, not really that relevant maybe to the audience, but I'm just curious because I work on a lot of Kubernetes like controllers and operators. If I want to hook into the Kubernetes API, use the service account, get a lease and stuff like that, that would all just work?
Yeah, so funny story. So we said we develop MirrorD for Teams. MirrorD for Teams is an operator. So we dogfood a lot. So and the operator runs in the cluster, and then the operator of MirrorD that spawns instances of MirrorD, we debug it using MirrorD. So this works and all the leases and everything. And we actually had a very tough bug where I'm trying to remember what exactly happened. Let me. What happened? Yeah. Okay. So funny story. I debugged the operator, and then I saw that it's accessing the external IP of the Kube API because it uses the Kube API, and I didn't understand why. And then what I found out is that we use Kubernetes, which is great for developing Kubernetes APIs in Rust. And the first thing it does, it looks up for a kube config. And we excluded by default stuff that come from /users because that's usually stuff we want to be obtained locally. We have a lot of defaults to make a very seamless experience. So it actually used my local kube config file instead of using the environment variables of the remote cluster. So I was like, it took me like 2 days to realize that was going on. It was tough, but yeah. And now we're explicitly we use only classic credentials. So, yeah.
Nice. I think that's the first time I've mentioned Rust, which I'm actually surprised about because normally, like, that's the first thing I try and say in every stream. But it is all written in Rust, right?
Yeah.
Yeah.
Everything that's not the extensions, which we have to conform to the SDKs of the vendors. Yeah, everything is Rust.
Yeah, I really like Kubernetes. It's a very cool project.
Yeah.
We do have some.
Well maintained also.
Sorry.
Well maintained also. Like we send a lot of stuff upstream and very responsive, very friendly. Really appreciate them.
Yeah. All right, we've got some questions. So let's start with the one from Sarar. If my local process runs on port 80 and the service is on port 88, can I mirror 8080 to remote port 8 locally? So do they have any control over the way the ports work?
Yeah, so maybe I'll share my screen for that because the good example.
Yeah.
So, like we said, we really like having, like, we desire the user experience to be that you can just plug it in and it works for you. But as you want a more advanced configuration, we have tons of configuration for you. So in this case, we're talking about the incoming traffic. So we have here port mapping. And port mapping, you can say exactly that. It's also auto-completed to the same mapping. So this says that, okay, locally I listen on 80, but remotely I want to steal or mirror 8080.
Okay. And does this just use whatever kube context I'm on? I'm assuming you're not having to provide any other information than just making sure that your current session is using the right. All right, you can also point to okay.
But it uses your local one. Yeah, we use the default API of Kubernetes, which does. You have a kube config env, which also kube context should set. So basically, yes, it should work quite seamlessly with the whole Kubernetes experience of your local machine.
And can I set the context if I have a kube config with multiple contexts? Or would I have to switch that locally first?
Yeah, you need to switch it locally first.
Yeah, I think that's probably expected, so no big deal. All right, Russell asked, sorry, I think I missed it. Are the files read just in time? So when a syscall is executed, or do you do any scanning, parsing to pull them at the start of the session?
You can answer it now.
I think we've seen that through the breakpoints, yeah. So.
Yeah, I actually saw that Mahul from our team answered in the chat, but just to reiterate, they're read just in time. We hook the file reads, and so when your process tries to read the file, that's when we pass it to the agent. Agent reads the file, pass it back to you.
Okay. All right, Wendt says, awesome. We will test this in our environment. It's good to see. Russell has been in your documentation and sees that it hooks into libc, so works with Rust as well as Go. I mean, I'm assuming it'd work with most applications. Is that a fair assumption? Are there any gotchas that people should be aware of?
Yeah, it works with most applications, like applications that I would say love people. And like the exclusion would be Go on Linux that tries to go to direct syscall mode, and there we directly hook the syscall calls of Go. So that's what Russell meant. Like we hooked specific. We have a specific shim or customization to work with Go. Currently, we work with Go only on x64, which is the common processor, and we need to add the same for ARM. but we haven't gone there yet. Usually, people just prefer to run it locally. So on macOS, they can't use directly call syscalls because Apple doesn't provide stable kernel API. So that's nice. Thank you, Apple.
Yeah, working on a Mac just gets easier and easier, right? Anyway, let's talk about, like, let's say I want to make my life easier for developers and my team. I think Metad is the answer. Now, do I just start going to all of my projects, all of my repositories, and adding the metad.json? Do I put makefile targets in where people can just run the metad CLI? Like, how do people get started? What's the preferred way? What's the lowest friction way for teams to start adopting this across all of their services?
So
in fact, let me prefix that, right? Because there's a bit of context in my head that I've not really verbalized. And what I was saying really is that this metad.json, does it just work with the VS Code extension? Does it work with the CLI? What's the preferred approach for teams moving forward?
Yeah. So basically, what the extensions do is they use the CLI. So everything works with a config file. So everything that you can do in the extension, you can do on the CLI. The extensions are just like giving better user experience and better settings when it comes to running from IDE environment. Like what we see, people sometimes they execute via the CLI using Makefile, using Justfile, using Bazel, and then they use the IDE. They use it to. We just had someone in the Discord asking about the Bazel. Not the first one. It's like the third person that asked about it. And then they launch it using Immunity, and then they attach the debugger, for example, using the IDE. That's less of how we see it being used, but of course, anyone can adopt it in any way they want. So when it comes to adoption, I think one of the advantages, like compared to other alternatives, is that you don't have to install it for everyone. You can, like, I'm Aviram, I see Immunity, I can just get started, and that's also what we see. We see people getting started, initially use it for a specific use case. Like I would say one of the first use cases that comes to their mind is that they want to debug. Like that's an ability we lost as backend engineers. We just add logs and tracing and deploy, and like in the best case scenario, we can attach a debugger to the remote environment, but like it's not very comfortable. And like the first thing they use Immunity for is for actually debugging using the IDE. And then as they use it as they use Immunity more and they gain and they get more confident with it, they realize they can just use it for developing on a continuous basis. So now I can just each change of code I do can just run it in a few minutes in a remote environment, see that it works, and then write the test. So instead of like thinking about all the scenarios I'm going to meet, what kind of database, what data in the database, what's the relation, I can just plug it in, see what happens. Okay, this works. Okay, let's write the test. Let's cover more, mild cases, but not like the extreme edge cases to cover everything, so it will work in any case. And yeah, I would say that's like usually the road.
Okay. Let's dive into this config a little bit deeper then. So right here we have an HTTP filter. We're doing a header filter. We're looking for the PG10 as Atherum. Is there any interpolation on this file? Can I use an environment variable to put in my username just to pull out certain things? And I'm thinking this is in a Git repository. It's shared with the entire team. Can we inject something in there?
Yeah, actually, that's a good idea. We haven't thought about it yet. Interpolating settings like the team is also on the chat, so guys, create an issue. So right now it's static. Like you can commit it, but you can. It's not something you can we interpolate or extrapolate for all of that matters. Unfortunately, but that's a good idea.
Okay, and are there any other L7 aware filters beyond HTTP? Does it understand gRPC, Kafka? What else is options there?
Yeah. So when we talk about like we divide it into two categories, like you have incoming and you have outgoing. So Kafka you pull. We don't consider it incoming. We talk about the network stack. Like, is it an outgoing connection? Is it an incoming connection? So on the outgoing level, which applies to Kafka, we don't do anything special. We just let you connect to the remote service. We do plan to have more like filters and smart application level protocol features. But right now it's just like plain connection. So anything you can connect to the remote service. And in terms of the incoming, right now we support HTTP 1, 2, and that covers gRPC. So as far as we know, gRPC is over HTTP usually, HTTP 2, and the headers of the metadata of gRPC, the path, everything goes into HTTP. So you can also use the HTTP primitives to filter and work with gRPC. So
Are there any problems with TLS that interfere with this, or does it just work out of the box?
yeah. So let's say the best practice when you use MTLS in cluster TLS, usually have a sidecar. The application doesn't do TLS. I hope for. I mean, like unless you do an operator, the TLS is done on a sidecar, and also in an operator. Actually, you can do a sidecar, but usually it's a sidecar. And then because MIMD enters the Linux namespace of the real process, we just get the plain traffic.
Okay, so the
also,
TLS termination happens at the sidecar, then the local traffic is unencrypted, and it should just work that way.
Yeah, but if you use TLS, you can't use the HTTP filters. You can just steal the port and then you terminate it locally. So that would work. Like that's how we develop with the operator, for example.
Okay, I think last question from me right now. So if anyone watching has anything they want to ask before we finish up, please feel free to drop it into the comment section. But I was just about to say, I'm looking at your config, but it disappeared. But it doesn't matter. I was looking at your config and you're targeting a deployment called IP info, I think it was. Does that inject does that work for all the pods in the deployment? Is it just a specific one? Does it even matter? I'm not sure. Like, how does that work?
Yeah. So in the open source version, what it does when you specify deployment, you just choose a random pod, like the first one it encounters, which means random. In the operator, it enables you to really work on deployment level. So now instead of stealing from one pod, you can steal from all of the replicas of the same deployment. Yes, good question.
Okay, awesome. All right. I'm not sure if Dimitri is on your team or not, but Dimitri has commented saying that some things can be overridden with environment variables, but not all. Is Dimitri on your team or just a random helper?
Yeah.
Yeah.
All right, perfect. All right, we got a question from YMO who missed the beginning. Shame. I guess you can always watch it back. It's on YouTube. But the question was, can I mirror to an app running on my host? Would be perfect for the build deploying cycle.
Yes, exactly. That's what MIMD does. And we agree. It's perfect.
Yeah. Just jump back to the start. Check it out. The demo was cool. Hope it helps. Question from Russell. When you steal traffic, can you steal a subset traffic with a certain header set? I think that's what we showed, right?
Yeah. So we show that. You can steal based on header filtering. You can steal based on path, and we're happy to add any more filtering conditions that users want. Like just request it.
All right. Thank you from YMO. I guess we confirmed exactly what they needed to hear. All right. Let's talk about the future then. I think we've covered the problem pretty well. I think we've seen that it's a really good solution. The integration with VS Code for any of those IntelliJ people out there, I'm sure it's just as good. But we now have a tool chain that allows us to develop with a pretty strong developer experience. What's coming in the future? You've mentioned MetterD for Teams. Maybe you can talk about more about there, and maybe what else is what's on your roadmap or agenda for the open source plan as well.
Yeah. So the idea is mostly to enhance the experience of MIMD, like cover more use cases and become like. So right now we start MIMD, and when we try to start from the very primitive, like we really like going very lean and see what users react to best. That's what we did from the start, and what we want to keep doing. We do have like a more like broad roadmap, but essentially that's what we do. But in terms of what we want to do, so the longer term vision is that MIMD starts with a very intuitive and naive way. So it just steals traffic and just redirects traffic to the cluster. Seems easy, but it provides a better user experience than any other solution you would have. But as we develop it, we had HTTP header filter. We're gonna have application filters for the outgoing traffic. So now you can duplicate Kafka messages. You can provide the best way to work on a remote environment without while controlling your effect on it. So the idea is to make MirrorD the tool you can use daily and enables you, let's say, the best way of isolating yourself while developing, while not really spinning up the whole environment. So you get the best of both worlds. You get a real mature remote environment while you're able to control and not contaminate it.
Nice. All right, let's going to ask the question that's been on my head for the last 53 minutes now. Why is there a GitHub light behind you and not a metal bear? I want to see one of those lights in the metal bear.
Sorry, what's the question? I didn't get it.
You've got a GitHub lamp behind you, right? The neon sign. I mean, I'm looking at the
Because
metal bear logo over here, and I'm like, that is a
free
perfect.
neon sign. Yeah, you don't get a free neon sign from Metal Bear, only from GitHub. So.
Oh, you need to make that happen for the next time we have an episode. I think that'd be an awesome LED sign. So cool.
We just have shots right now. Can see
Nice.
it. 1 second. Yeah.
There we go. The full thing. Nice. Very cool. Like
By the way, Eyal is the creative director of Metal Bear. All the ideas of design that were coming from his steaming head. I'm like, oh no, it's this
And
good.
I do outsource, so anyone in the audience.
Yeah, looking to brand enhancement, but he doesn't do actual design. He's bad at it. Like he's on my level. So.
Yeah, I mean, I do a lot of front end design, but I go as far as black text in my background. That's as good as I can get with CSS.
Yeah. Same.
All right, where can people learn more? Do you have a Discord, a Slack community, a discourse? How can people get involved? Do you have PRs welcome, issues, easy, get started, all labels? Like, tell people how they can help you out with what you're doing at MirrorD.
Yeah. So we have a Discord channel. We like to see it as a backend engineers community. So it's like you have MirrorD channels and you have general channels. You can use any of those. Like if you use MirrorD, you can ask questions for support or maybe get mentored for a PR. And yeah, we welcome PRs to all of our repositories. Like there's the open issues, we try to label those. So if you want to hit an issue, let us know. Happy to jump on Discord, explain it further, help you get started, help you get into Rust, get into Kubernetes, this kind of stuff. I'm not sure if it's the first project to get into Rust, to be honest, because we have maybe some points that are simple. But like if you want to do advanced Rust, I would say that's a very good project to look at it. Yeah, so happy to see all of you in Discord. And feel free to reach out, Discord, GitHub, I don't know, any means of communication that is not coming to my front door. Like you can come into my front door, but like invited. So.
Awesome. Well, I encourage people to join the Discord, check out the project. If you enjoy it, you run into any problems, open issues, comment on this video, and we'll do your best to get you some help. We have one question that has snuck in right at the end there, so we'll answer that and then we'll wrap up for today. But YMO asks, there is Go code in the repository. Does that mean that you have an SDK in Go people can embed?
So that's a great question, actually, because we don't have any SDK. You just run your process using MirrorD. I didn't show that, but you can run curl using MirrorD. Like we had a user saying that used to upload configurations into the cluster. I assumed it was like a XTP or something like that. And he just used curl to post that request into the XTP. So you can run everything on your machine. So Go compiles into a binary, and then we run it using MirrorD. So anything that is a binary, you can use MirrorD with. No SDK, no any integration needed to do from your side. Just plug it into your IDE and start working on
Awesome. Thank you for that. All right. We'll finish with Russell's comment saying, thank you for the demo. MetterD looks like the future of developing in Kubernetes. I don't think I can say anything better than that. So we'll wrap it up. Thank you both for joining me and for sharing your knowledge and everything that we've learned about MetterD. Is there any final words before we finish up?
Wait, we show pets? I can bring Jimmy in.
Yeah. Go
no,
for it.
Jimmy, come.
It was trying. So.
This is Jimmy. He's a little demon. He wants to.
Yeah, anyone joining Middleberry gets a free. Yeah.
A free dog?
Free dog. Yeah. Did we not mention that?
All right. I'll send my CV right after this call.
Yeah.
Yeah.
All right. Any more pets to be shown? You got one there?
Yeah, it's here. It's here. It's haunted.
And there's all that.
I don't have mine in my office. My pets are all at home, but next time for sure I'll bring some in for the day. All right. Well, thank you again. It's been an absolute pleasure. I really love what MetterD are doing. I hope everyone else enjoys this demo, and I'll see you all soon. Have a good day.
Awesome. Thank you. Bye, everyone.